Hello, good evening. This is the PARQE's Capstone team, Fall Winter 2023-2024. I am Michael Doe, the team lead for this capstone, and my team members are Alan, Andrey, David, Fairuz, Jordan, Matthew, and Ryan. Okay, so a description of the project. This capstone aims to develop the PrusaSlicer automatic routing and quoting engine, also known as PARQE. PARQE is designed to modernize and automate the 3D printing submission workflow in the EPL lab. PARQE provides customer web page with standard form fields to guide them towards submitting a print order. Additionally, EPL staff have a suite of screens to monitor and manage orders. Once a customer submits an order, PARQE will generate a print and provide the filament unit multiplexer engine with the said order from which it will be printed. And now we're going to be watching the demo. that is the end of our demo, and we'll be continuing with our project details.
So hello everyone, my name is Fairuz. I'll be talking a little bit about the project overview. The project consists of a user submission hub, which provides a user-friendly interface for the student to easily submit their 3D design file. And it also consists of PrusaSlicer integration, which automates the coding, slicing, and print setting configuration using the PrusaSlicer CLI. It also has managerial review system, which is a quality control checkpoint that allow EPL staff to review and approve or deny crucial printer settings and orientation before the actual printing process. On this webpage, staff can also verify payments on approved orders, view printing orders, view the backlog of previous denied or finished orders, and manage the filament inventory database of currently available filaments in the lab. It also consists of Octoprint and FUME integration, which creates a payload containing G-code and JSON file with desired configuration, which FUME Capstone will unpackage. It also has CashNet integration, aims to automate the payment process, providing a direct link to CashNet for students to make immediate payments after managerial approval.
My name is David, and I'll be going over the target audience for our software. Our first target audience are people who want to print their 3D models, mostly going to be PSU student, faculty, or staff. These are going to be customers who's going to submit the 3D designs through our users page. And our second target audience is the EPO staff. These are going to be people responsible for overseeing the 3D printing operations and who works in the EPL lab. They're going to use the system to review, approve, deny print settings before printing.
And we'll be moving on to our main features.
And there are three main components for software. First is like our user page, user order upload page. We also call it the user API. This is where the user uploads their 3D model and interact with our system. And second, we have the management page. This is where the staff is gonna review the orders and control order workflow. And this is where the staff is also gonna manage the filament inventory stuff. And we also have the backend and database, which work together to provide persistent storage for our orders and tracked information for our orders. Our backend also send email notifications and instructions for the user so they could go through the printing process. And our backend also is also in charge of routing the pages and it communicates with the front end to send or receive data.
Hi, my name's Alan, and I'm going to be talking briefly about the print job upload page and user API. So this is how a user interacts with our system in order to upload a 3D model and configure print settings. So information that we collect from a user is their email for communication purposes. File upload types we allow are .stl, .3mf, .stp, and .step. Users will be able to select filament types based on the current inventory of the EPO lab. Settings that a user can configure for their print are nozzle size, layer height, infill density, quantity, and then they can specify any notes if they wish to give additional instructions to the staff to review. So after a user hits submit, the JSON payload gets sent to the backend, and the user will receive an email with next steps such as confirmation, payment, and results.
Hi, my name's Matthew. I'll be talking about the staff management page. The staff management page acts as the hub for EPL staff members to interact with submitted orders from the front end or from the user page. So it consists of 7 screens that allow the staff to interact with the order at every stage, from initial submission, where they're able to approve or deny the order, to once approved, verifying the payment for that order, and once verified, queuing that order to print and sending it off to the fume team, which will handle it for printing. And once finished with printing, it will be closed out and end up on the closed orders page. And the staff management page also includes the filament inventory, where staff is able to indicate what filaments are available and what colors they're currently available in, which reflects onto the user page.
Hi, I'm Andrey. I'll be talking about the backend. PARQE uses a simple backend framework, Flask for the server and PostgreSQL for the database. The resulting structure is very simple. Flask routes traffic, handles requests, and defines the behavior of the entire service. The database has a cascade of tables to represent the status of the orders in the service pipeline. When a new order is made or an existing order is approved or paid, Flask advances the order in the cascade of tables all the way up until the order is closed. A benefit of Flask is its built-in logging system. Everything from requests to exceptions is logged, which makes analyzing traffic very easy. The system is also very customizable, so it can be as verbose as you want it to be. Gathering data such as common filament types or colors is just a few lines of Python. All communications with the client after the initial order is done through email, which is why PARQE requires email confirmation. Specifically, there are 3 points of contact: order confirmation, which also verifies the email; order approval by staff, which requests payment; and once the order is finished. The backend serves 2 fronts, the staff side and the buyer side. The buyer side takes orders, and the staff side oversees the orders traveling through the pipeline. After payment is confirmed, the order leaves PARQE and enters Fume via an HTTP post request. Once the print is finished, Fume notifies PARQE.
Hello, I'm Ryan. I will be going over the Octoprint/Fume connection. Basically, PARQE's role in this is to slice the code, get the settings ready, and we deliver a payload of information with the sliced code and the settings to the Fume team, who then performs the actual routing of the print job to a specific printer and maintains that process.
Hi, my name is Jordan. I'll be speaking about our additional and future features. A couple of things that we added to this project was a G-code previewer that allows the staff to look at a print before they print it. We verify staff accounts using OAuth. We've got an email search filter that allows all of the tables to be searched so you can find which job you're looking for. CacheNet implementation allows for payment from the user. We've got a dark mode, so it's not hard on the eyes. Moving on to our future features, these are things that we have for others that come to this project to add to it. Getting the application hosted on PSU's area network just ended up being out of our scope. Configurable setting fields in the print upload page, as well as additional depth when handling complex prints, would make this project a lot stronger.
And I'll be talking about the process.
So the broad architecture we've kind of outlined previously. This is a visual representation of the pipeline, which starts on the right side with the customer, which has their own set of interactions, and the left side, staff members have their interactions as well, which follow the features we listed in the previous segment.
So here's the list of everyone who worked on this project. For print job, upload page, and user API, Alan; management page and staff API, Matthew and Jordan; backend and database, Andrey and Ryan; Octoprint, myself, Fairuz; David and Ryan. And here's the responsibilities. So we kind of split into a group of 2 to make sure we kind of able to finish the job on time. the member also move around as needed. And we also ask for assistance and also have to review the pull request.
Okay, so we're going to be talking about how the development process actually happened for the PARQE capstone. So first off, we were using an agile framework. So we had 2-week sprints. Initially, we tried to do 3, but we came to the conclusion that 2 allowed us to progress in shorter intervals, which allowed us to review and ensure that our product was working. We have weekly stand-up meetings. Initially, in our first term, we had 2 meetings per week, Tuesday, Thursday. However, we felt like that was unproductive, and we stuck to 1 after that. We have bi-weekly refinement meetings. These are meetings in which we fill up our backlog and plan for work for the upcoming sprint. Next, we have stories within application components. So within the applications of components we saw above, the user API, staff API, etc., we had stories dedicated to those specific components. Majority of work was done individually. Individually, yes. And each of these pairs of people worked very closely together. People also moved around, which gave us a lot of hardships. However, we were able to bounce back by asking questions and learning from our mistakes. Meetings, providing settings to discuss retroactive board interactions, and smaller scope changes were discussed between meetings as needed.
The most significant challenge was figuring out how 3 key pieces fit together: staff, client, and Octoprint. All 3 would need to interact with an order, sometimes more than once. Because the pieces were so tightly knit, we decided on a central server to link all 3. This design is a solid and generalizable foundation for future development efforts. For the framework, the choices were Express or Flask. Flask was chosen fairly easily for several reasons. Python is simpler than Node, and Flask is better for small-scale projects, as well as the team had more experience with Flask. The team was originally divided into 5 groups: staff, client, server, database, and Octoprint. Since this was the first sprint and there was no integration between the components yet, organizing work detail was a challenge. Octoprint was especially hard, as it is the last step in the pipeline and depends on many factors that precede it.
So continuing the major steps we took, component integration, so integrating the staff page and the user page and the backend to all communicate and for information to flow easily between those was one of the major steps that we tackled throughout this project, as well as advanced component development. So as features were added onto the components, it was a continuous cycle between integration and development so that all the information flows seamlessly through the components. And lab integration was another large step for our group as well. And this was making sure that our project was able to run as it should on the lab computers. And then testing and deployment was one of the final steps we took. And this was just ensuring that our application is as bug-free as possible and prepared for the next group to take it on.
We did have some unexpected events occur over the course of the entire length of the capstone, with the a rather large one being a winter storm, which knocked a lot of power out and caused some rather extensive damage. Not getting network access through IT was a bit surprising to us at the time, but realized we were out of our scope, like we said. And the Fume capstone, beginning there, Capstone also was a bit unexpected, since we had planned to integrate Octoprint into our application, but found out that they made a bit more sense for them to actually integrate what we wanted to at first.
Our sponsor for this project was Ed Ivory of the EPO. Overall, he was very pleased at the progress that we accomplished during this capstone. He noted that all elements that were communicated clearly from the onset of the project were delivered, but mentioned some specifics may have been lost in the communication pipeline. We compiled a list of future features in order to help outline work for a future capstone group to expand on what we did. PARQE is intended to integrate with the Fume project. Eventually, PARQE will become the sole application for EPL printer management.
For our lessons learned, we found that effective communication was a big key to having the success that we did have and for further success. So just making sure all parts of our puzzle are communicating with each other. Our meetings, we found a bit of a happy medium in just not having too few or too many meetings. For our task tracking, we found it was important to ensure the work prioritization. And we found that it was important to gather more knowledge about our subject.
And in conclusion, Team Monarch is proud to deliver the first stage of PARQE application to the EPL, along with the included functionalities. We believe our product is good, staged around ground for the planned future development beyond our own scope. We would like to thank our sponsor Ed for his incredible encouragement, insight, and vision. EPL staff member Ben for his advice, experience, and responsiveness. The Capstone director Bruce for providing an excellent medium to develop our skills and conclude our journey at this university. Thank you guys very much.